Good morning, Fancy Meat computers. I think that your clock's a little slow. I've got 9:30 on the dot, so yeah, I don't know what is going on over there, but let's see. Video seems to be working fine. Just have to check to make everything. Oh, there we go. Wonderful. All right. You've out-Germaned me. Wie geht's? S gate. It goes. My German does not extend very far beyond, hello, how are you? I'm fine, and you? I think that the word octopus is the same in English as it is in, as in German. But anyway, so, good morning, everybody. Hopefully everybody had a nice weekend. Mine was pretty good. Thanks for asking. Overcast today. Somewhere in the mid-teens in terms of temperature, so we're starting to clamp down on the warm temperatures. I see people riding around with jackets and on their bikes, so you know, fall is afoot. Fall is afoot, and it soon will be winter. In fact, the wonderful thing. Apparently the prediction from either the Farmer's Almanac or Environment Canada is that in this part of the world, winter is going to be especially long, cold, and snowy. So look forward to that, eh? Anyway, so let's continue our exploration of C, the C programming language, since this is software engineering. Wait, it's not software engineering. This is Mectron. I forgot to change the code. Last year it was software engineering. This year it's mechatronics. I should change the code on the slides. I think this isn't the first time. Yeah. So, we're going to talk about functions, library architecture, and recursion. So, quick question. Let me poll the class. Do you a recursion? No. What is your familiarity with the concept of recursion? That's going to be interesting today. So, right. Abstraction, satisfaction. In C, functions are the basic units of abstraction. So, what do I mean by abstraction? When we are programming, very often the degree to which our lives are made easier has to do very strongly with the types of abstractions that are available to us. So what a function is it's an abstraction of commands, right? You are able to take a set of commands, give it a name, and then refer to it by that name. That is an abstraction over commands. In something like Python, when you use classes, you are abstracting over both commands and data, right? Because you're able to bind functions to particular pieces of data because that's what a class is, right? So in C, our basic and most fundamental unit of abstraction is the function, and we don't really get much more than that. We are able to bundle. We have the capability of bundling variables together once we start talking about structs, but we won't get to structs for quite some time. And they're not really that useful at this point in the game. So it's basically all you got is functions. So we're gonna talk about functions. So there are functions in C are highly similar to how Python implements functions. However, there are some important differences. Number one, winter is hockey season. Yes, for sure. So functions in C highly similar to how Python implements functions. However, there are some important, I said that already. The return type of the function must be indicated where Python uses the def keyword. So in C, you don't have a particular keyword that calls something out as being a function. It's sort of, it's the place that it's put and the manner in which it's given type attribute, type annotations is how you tell if it's a function or not. In the absence of a return type, GCC will give a warning and the return type will default to integer. So that's kind of interesting. You don't have to actually include a return type. However, if you want anything that's non-integer to be your return type, then you have to include your return type. And it's generally speaking a good idea to have the return type in there anyway. So, you know, it makes everything more clear. Once again, curly braces are being used instead of colon and indentation. We should be used to that by now. The arguments must also have their types declared. Again, default is int. While a return statement is not required, GCC will complain if one isn't present. So, here is a direct translation from Python into C. So if we have a function max, which takes two things and finds the maximum of the two of them. I say things because this could be a large number of different things. In C, we have int max takes an integer x and an integer y. If x is greater than y, return x, else return y. Note the semicolons, curly braces, and direct type annotations. Otherwise, though, like, the structure itself is shockingly similar, right? Like, there's not a huge degree of difference here between Python and C, right? Everything is more or less in the same place, at the same time, in the same order. It's just a matter of including some additional typing information. So, let's take a look at the following poorly written function. Very poorly written. So this is basically the same, but with the this is basically the same function as we had previously, but with the return statements commented out and all of our type annotations removed. While this will technically compile, the following warnings are found. Number one. I know what the problem is. It needs to be recompiled to get my little buttons at the top. I need my buttons. I have to have my buttons. Got to have my buttons. Gotta recompile. It's in LaTeX when you're generating a document, in order to also generate the table of contents information, you have to regenerate it twice. So you can see I have my table of contents now. So there we go. Boop, there we go. In. There we go. Cool. So, we've got the following warnings. Return type defaults to int. So, return type, it's defaulting to int. Warning, type of x defaults to int. Same for y. Warning, control reaches end of non-void function. So, we could call could we call the function in the terminal, or is it in the main function? So okay. the way that you make this stuff interact with terminal, generally speaking, in order for it to be compiled for execution, it has to be in a properly formed C file. Now, you can perform a procedure where you take a C file that has no main function. You can compile the function definitions in there for use by other C programs. This is called creating an archive or creating a library. So you can have a pre-compiled library, and I guess hypothetically there might be a way of being able to execute like C library functions directly from terminal. I'm not sure what that would be though, and you're starting to get into sort of roundabout. You're starting to get into roundabout territory of that's not the way things are normally done. Let's say the normal way to do that is to write a wrapper for that wraps it inside of a main function and then compile and execute that. So in this case, for function max in C, does it replace the main function or is it just inside of the main function? Okay, that's a good question. So no, this wouldn't be inside of main. It would just be in the file. Let me do an example. Let me do an example. Examples. Create a folder, topic 4. Boop, 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 boop. There we go. Cool. So, get it. Example.c. So, stdio.h, or include stdio.h, int main void int max int x int y. If x is greater than y, still getting used to this keyboard, guys, return x, else return y. There you go. And from this, you would say int a is equal to 6, int b is equal to 7, print an integer which is on a new line, which is max of a and b. That should be a C program. Let me just open a new terminal so I don't lose my editor. Boop, 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 boop. There we go. GCC example. Warning! Aha! Printf. There we go. A.out. 7. So there you go. That is how you use a function from main. So one of the interesting things about this, and I'm jumping ahead of the slides a little bit, but if you copy this down here, right, in C, you get a warning, implicit declaration of function max. So max is being used before it's defined, and C, generally speaking, hates that. In C, it goes through the file sequentially, right? And puts things into the namespace as it runs into them. So with this, max doesn't exist yet, although a definition for it is provided lower on. The way that you get around that is by providing what's called a function prototype. So if you take just the type signature of the function and put it at the beginning of the file, terminated with a semicolon, then everything's fine. So what C needs to know when it hits a function is not the full definition of the function, but just what the type signature is. So this tells it what the type signature is, so that avoids our problem, and you can see that we still get the same result. Whereas, if we did not have this type signature, putting my leg to sleep here, if we got the implicit function declaration here and then ran it, we'd still get it, but to clear the error, we need to provide the type interface, which is actually a feature that was borrowed from C++. So let's see here. If you don't mind me asking a question, are you allowed to use %.4 for question? So okay. So that's a question about the assignment, which I will answer briefly. So for question 7 in the first assignment, there are two problems with using %.4f and the printf statement. Number one, your output for the assignment questions must not be a printf statement. It must be a return statement. All right? The return value of a function is whatever you put here, right? If you print stuff, that's not properly outputting it. And taking input from standard input is also not what we're looking for. When we say input, we mean function arguments. And when we say output, we mean function return values, specifically and exclusively. Print statements have nothing to do with it. So, since that method that you're mentioning is tied inherently to print statements, there are some functions you can use which aren't, but, you could use a string conversion function to convert it to a string using that method and then back convert it to a float. But no, you have to round it numerically, because the other thing about using .4f is that doesn't modify the value of the underlying variable, right? It's just a display thing, right? So you need to actually modify the actual variable. So yeah, hopefully that answers that question. Can we do that in the main function for your assignments? Or is this something that I say to avoid? Yeah, so don't put anything in the main function that you don't intend to lose, because when the autograder goes through your assignments, it's going to delete everything that's inside of your main function. So don't just tests in main. Just tests in main. Anything you want marked has to not be in main. Okay? I want to make that as clear as possible. Don't put anything in main that you intend to be marked. Is making the function outside of main and calling it in main the way we should be coding problems for the assignments? Yes. Yes, 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 yes. Everything in main will be removed by the autograder, so make it inside the function and then test your function in main. Yes. Thank you, Avery. Is your main function supposed to be the first function in the file? Nope. Typically, it's the last function in the file. Because, for the particular reason that was stated here, there's no particular, supposed to or have to. There's no particular rule about it as long as you're using function prototypes and, you're not running into these warnings. There's no constraint on it, really, but, You could make both arguments. You could say it makes the most sense to put main up front, and it makes the most sense to put main in the back. Generally, when you're programming in C, main is not going to have a lot of stuff in it. Most of the actual work is going to be going on in functions. So, yeah. So, let's see. I initialize the function at the top. Yeah, so we have slides on this, but yeah. This declares the function, and this is it's like when you declare a variable, you can declare it separately from instantiating it, right? I can say int int a, and then down here I can say a is equal to 6. It's kind of a similar process. I'm saying this function exists, now this is what it is, but later, lower down. So, good. Can you return strings in C? String is not a primitive data type in C, but you can return a character array, or you can return a character pointer. So yes, you can, but not you. It's not called a string, but yeah, you can. I thought that the function in question 7 was void. Oh wait, maybe I'm. That's the one with the interaction. That one actually does have some interaction, right? Yeah. Let me take a look. Sorry guys, I may have forgotten what I was. Let me take a look at the assignment. Question 7. Oh yeah, okay. Right, okay. So yeah, this is gonna take I'm sorry guys, I forgot that this question was a one that actually did require some degree of input and output. Doesn't actually ask for a return value, does it? Okay. Well, okay. So question 7 is like the only question in the course that's not going to require an explicit return value. All the interaction will go on in standard input, standard output. Sorry, guys. Yeah, it's like this question is like the exception to the rule, unfortunately. Unfortunately for me, I forgot about that. Yeah, okay, so using printfs and scanfs is acceptable and the point of this question. So, yeah, you can just use .4f in this case. Sorry about that. I was incorrect. Yeah, okay. So, let's see. Where are we here? So does that mean that all the inputs for question 7 would be from standard input? No, I was wrong. No, you're supposed to use scanf for this one, yeah. Would I prefer you to use this form? This form is going to be useful. It's not explicitly required, but like generally speaking, when we provide you a code stub in an assignment, we'll provide you like the function prototype because it's very, very important that the functions have the correct type signature in order for them to be marked. So generally speaking, that will be provided, and like you would be filling it out. So, yeah. Yeah. So, well, you know, yeah, it's rounding. Okay. All right, that's enough questions about the assignment. You have to move on with the slides. So, function prototypes. In C, as in Python, in order for a function to be in scope, it must be defined before it's used. In the previous example, if the function max is defined after main, GCC produces the following warning. Warning, implicit declaration of max. Did you mean main? Early versions of C did not check for correct function usage at compile time, so the error would show up at runtime. Function prototypes solve the issue of having function typing information available while maintaining C's back compatibility with programs written before static function checking was added to the standard. So the reason that this is a warning and not an error is because old C programs we have to still be able to compile them without modifying them. So the warning means that it'll still compile and it can still execute. But, you know, in any other place, like in any other language, this would be an error. That is why this is a warning and not an error. Yeah, precisely. Function prototypes continued. To solve this problem, C has borrowed function prototypes from C++. A function prototype is syntactically the first line of a function declaration terminated by the semicolon character. It is good practice to put function prototypes immediately after your preprocessor commands, i.e. your include statements. So, generally speaking, if you're going to include function prototypes, they should go right in the header material for your file. This declares the function up front, so its definition may now occur anywhere in the file without generating warnings. There you go. So, library architecture. Computer architecture is a set of rules and methods that describe the functionality, organization, and implementation of computer systems. And if you've never seen this guy before, this is a photograph of the Minecraft library, which is a library that's used to smuggle banned books into... Like, it's a library that's filled with books that have been banned in various countries, so that, you know, if you're living in a country that bans books, you can read them in the Minecraft library. So, header files versus libraries. Things that are useful. The ability to call functions defined outside of our source code file. The ability to precompile these functions. The ability to share library functions among many programs. These purposes are served by the library system. So, generally, this is how a library works. You have header files, which contain the prototypes of functions made available by a specific library. You have the library itself, which are files in which the functions specified in the header files are implemented. There are two main types, static and dynamic. Because their functionality is so closely linked, when a person says a library, they usually mean both the library and the header file taken in combination. So, static versus dynamic libraries. Static comes from the Greek word statikos, meaning causing to stand. That is to say, not moving. Static libraries contain object code linked with a program, which is then integrated into the executable. They are included at compile time, that is to say up front, and consequentially the compiler needs to be able to find it. Dynamic libraries, on the other hand, dynamic is derived from the Greek dynamikos, meaning powerful. Dynamic libraries are linked to the executable at compile time, but the implementation of the linked function is loaded at runtime rather than at compile time. Linking resolves undefined references in the source file, and dynamic libraries may be shared among many programs. This is also true of static libraries. The main difference, like one of the primary differences, the main useful and important difference between static and dynamic libraries is that with a dynamic library, that library might be hiding out in your operating system somewhere, and your operating system can update that library, and your C program does not need to be recompiled, because the updated object code that comprises whatever function you needed, that object code will be updated whenever the operating system updates the library. And because it's loaded at runtime, not at compile time, the precompiled code from before can run the new code. With a static library, that's impossible. In order for a static library to be updated, you have to recompile everything that uses it. So yeah. Well, you should continue to pay attention then, because we are going to have examples, yes. So, header files. Let's talk about header files somewhat long let's get into header files. So, from the GCC documentation, header files serve two purposes. Number one, system header files declare the interfaces to parts of the operating system. These are things like printf and scanf, which would be considered to be so basic that it's a part of the operating system. You include them in your program to supply the definitions and declarations you need to invoke system calls and libraries. Your own header files contain declarations for interfaces between the source files of your program. Each time you have a group of related declarations and macro definitions, all or most of which are needed in several different source files, it is a good idea to create a header file for them. By convention, header files have the .h extension. So, essentially, for a header file, you take things like your function prototypes, possibly also include statements, and when we get into macros, you would put your macros in there as well. You take all of this stuff that's like not the actual functions or not the actual function implementations, right? You collect all of that stuff into a header file. Basically, you remember how I said that this stuff was header material because it's at the top of the file? Well, basically what a header file is you take this stuff and you put it in its own file. You call it .h. So there you go. There are a number of headers which are provided by default, which contain a number of interesting and useful things. We're going to be going through a number of these over the course of the course, but actually not as many off this list as you might think. Yeah, there are two of them. So, you've got assert, which allows you to do assertions. C-type, functions for character testing. Errno, error reporting. Float is floating point size limits of the system. So not floating point operations, but if you need to know like how big a float is on the computer that you're currently working on, like if you're creating a file that's or if you're creating a program that should be compatible to different architectures, different architecture sizes, then it's useful if the computer has defined in it somewhere, how big a float is on this system. Then you can load that and use that information inside of your program. Are you allowed to use extra headers in your assignments? Yes, if you want to write headers for the assignments, go right ahead. Yes. Math is useful. Math is all of your math stuff like sine, cos, and square root. Signal is kind of like error handling. C doesn't really do error handling, but signal is as close as you're going to get. Signal handling is as close as you're going to get to error handling in C. Standard def, some common definitions, type definitions, and stuff like that. Standard I/O, you should know by now. Standard lib contains function prototypes for conversions of numbers to text and text to numbers, memory allocation, random numbers, and other utility functions. Standard lib is one that you'll probably use a fair amount as we go through the course. String.h, definitely. We have a whole lecture on all of the functions that are in string.h, or a fair number of them anyway. And time, if you want to manipulate time and date. So, here is an example. We have 3 files. We have top.c. That'll be our top-level C file. Contains a main function that uses the max function, right? We are including mylib.h. Mylib.h, there we go. It's just the header. And then mylib.c is the definition of the function itself. Every time you write 1.0 in C, it shows as a double. That'll probably be a like a double precision floating point number is 64 bits, and everything's on 64-bit architectures now, so that would be why. For example, if you were to save the previous max function as a file called max.h, then you could include it as a header file in another C file. So you can do that, to answer David's question. You can do that, but for the assignments, please make sure that however you configure it, everything can be loaded just from like a standard. Make sure that when how to put this. So when we auto-grade your assignments, we invoke GCC to compile it. If your file requires a weird GCC invocation in order to actually produce the executable, that will be a problem. So there's a way of doing this where you have to include lib.c and top.c. Like this one that we're working towards, you're going to have to include top.c and mylib.c in the compiler invocation. Like this. This is going to be a problem on... that'll cause problems if you're creating these where they're not intended, because for the invocations of GCC that we're going to use to compile your assignment questions, it'll just be like GCC question4.c output question4. Like, we won't know to include other files if you write them in this line. Fortunately, there's a way of getting around it. If you just include mylib.c as well as mylib.h, then the C file knows to look for the other C file, so you don't need to include it in the GCC invocation. So there you go. That's how you would do it. Yeah. You can put include statements inside of header files, or you could put them in the main file. Depends on where you need them. Like, this guy doesn't need any... This guy does not need any other functions, right? It doesn't use print or printf or anything like that. So, yes. I'm a bit confused about mylib.c and mylib.h. Are mylib.c and mylib.h two different files? Yes, they are two different files. Could you combine mylib.h and mylib.c if they're two different files? So, it's like, yes, you could combine them if you wanted, but if you really, like, if you were going for the most simple solution to this, you would just include this function inside of top.c, and then you wouldn't even worry about doing a library. The whole point of this is to show you how libraries are typically constructed, right? But yeah. I can probably end this poll. So most of you don't know what recursion is, which is fine. We'll learn it. So, note that lib.c does not contain a main function. So that's important to know, right? So libraries, generally speaking, don't contain main functions. How it works in C is that the topmost or top-level file will contain the main function, and no other files which are imported by sort of in your import hierarchy should include a main function. That's how it works in C. Only the top-level file should have a main function. So, all three of these files are compiled and linked with a single invocation of GCC. GCC wall top.c mylib.c output top. Running GCC on only top.c, omitting mylib.c, will it result in an undefined reference, which is an error. So, right now, you can see we are importing mylib.h. Mylib.h does not import mylib.c. So, when it's loading mylib.h, it's just loading the prototypes. It's not actually loading the definitions themselves. So we provide the definitions by including that file in the compiler invocation. In Ubuntu, when compiling a program with math.h on the command line, I had to include -lm to the end of the command. Did you really? That's interesting. We'll have to see. We may have to include that. Yeah. Let me try that. And then let's say printf square root of 30. I didn't get that warning. Are you using some IDE? It worked in VS Code, but not on the command line. Well, you know what? Why don't you post your source code to Piazza privately? Obviously don't post your solution to the problem, but if you post, if you do a private post on Piazza, I think we can probably figure it out. Potentially on Mint, the process is different. Well, Mint is Ubuntu. Mint and Ubuntu are very, very similar. Mint was forked from Ubuntu. And the way that GCC works on any Linux distribution is not going to be significantly different from any other Linux system. I suspect it's probably some artifact of the using VS Code for it. The difference is I'm not using any editor. I'm just using a, maybe it's a Windows subsystem for Linux problem, maybe. But you should know that we're going to be doing GCC on Linux. So on Linux, you don't have to do that. I don't know, maybe, but yeah, if you post your code privately to us, we'll take a look and see if there's something, obviously, So, someone again asking about the assignment. So we shouldn't have any print statements in our codes, even when asking for input. So question 7 is an exception. Question 7 on the assignment, you do need print statements, you do need standard input, but all other questions in this course ever use function arguments and return values exclusively. Oh my goodness, so many questions about the assignment. For the assignment, do we save each question in a separate file? Yes. Use the structure as given, please. I gave you guys a, is this, this is the wrong class. I'm looking at the Avenue right now. Okay, so you see this zip file that contains all of the stubs, right? It contains a directory structure, and all of the files, all you have to do is basically drop the functions into these files. It's very simple. But if you don't follow this structure, then the autograder is going to choke on it. So follow this structure, please. But yes, every file, every question gets its own folder. In each folder, it's questionx.c, where x is the number of the question. That's the naming convention. So, please be sure to follow the instructions carefully. So, it is a stylistic recommendation to write header files for your C files below the top level, especially if they are large. This emulates the way other programming languages use packages and modules. However, the header file may be successfully omitted. In the previous example, if we change mylib.h to mylib.c on line 3 of top.c, and omit mylib.c from the GCC invocation, then everything works. If you just have, the other thing that you could also do is you could include mylib.c inside of the header file. That would load this guy into the header file, and the header file would be loaded into top.c. So, my goodness. When you run your code on VS Code, it creates an .exe with a .c file. Will that be an issue? We won't be looking for it. We aren't interested in, like basically any executable file is useless to us. We only want and need the C code. All right? We will be recompiling everything from source. No exe, it's like if you include extra files in the assignment, then it's like, okay, if there's an exe file in there, it won't make any difference, but don't expect us to mark it either. So, dynamic libraries. The procedure for creating a dynamic library is operating system dependent, but the goal, in general, is to create either a shared object file, a .so for Mac and Linux, or a dynamically linked library file, a .dll, in Windows. Some of you guys may have heard of DLL files before. The general procedure is to perform a special compilation to generate the file, and then to put the file somewhere in your specific operating system can find it. If set up properly, a dynamic library can be used by programs written in languages other than C. And I'm not just talking about C++. Be warned, messing around with your operating system's hidden folders can have serious consequences. Never mess around with a computer like this if you haven't backed up your data, and don't say your professor didn't warn you. Oh my goodness. Jump. There we go. So, good. That's about our lecture for today. But yeah. So, if your code doesn't work in Visual Studio, keep in mind that Microsoft has its own C compiler that's not GCC, right? Microsoft's C compiler is not compliant with the C specification. There are only 3 that are, and it's not one of them, right? GCC, Clang, and some other one that I can't remember at the moment. So we will be using GCC to compile your code. Therefore, if your code does not compile under GCC, it's not correct. And if your code compiles under GCC, it does not have to compile under any other C compiler. GCC is it, it's sufficient, and it is the good one. All right? Should we git ignore all files that are not C? You could git ignore all files that are not .c. I would say leave .c and .h files. But yeah, yeah. Yeah, git ignore. For those of you who don't know, a git ignore is you can set up what type of files like a Git repository can be taught to ignore specific file extensions or specific file patterns, and you know that's basically if you just go into the root directory of your Git repository and make a file called .gitignore and put like file patterns in there, the Git repository will automatically ignore those file types. But, you don't have to do that for this. It's, if you like things that look clean and pretty, that's how you would do it. But, yeah. Yeah. Favorite lecture, don't tell the other profs. Ha ha! Thank you, Pedro. Yeah. Well, I like to think we have fun. Today's material was a little bit drier, but, it's still very, very useful and important stuff. Yeah. I'm actually kind of thinking, like, with my 1xC3 class, I've got some, like, labs. Like, 1xC3 also does C programming, but it's got a much heavier Linux component. And I have a good exercise on static versus dynamic libraries that I'm kind of inclined to sort of post to the Avenue group out of, like, if anybody has any interest in it. I'm not going to make it an assignment or anything, but, like, if you want to, like, really learn well how to create a dynamic library or create a static library, it's like I banged out this exercise over the summer, and I think it's a really good one. So I might actually, just post a lot of the 1xC3 material if you guys have interest in it. It's not. I maybe. Yeah. Yeah, I wouldn't like I wouldn't make it for marks or anything. It would just be like extra bonus material. But if you guys would you guys be interested in that? Would you guys be interested in like having the 1xC3 labs available? Like, I kind of feel a little bit guilty, actually. Ha! Dorian wants it. Awesome! Just for Dorian, then. I feel kind of a little bit guilty about the way that this course is oriented, because, like, teaching just C programming when you've done when you've put together a course that does the C plus the Linux, it's like I feel like 1xC3, like, you get a lot of stuff that's really, really useful that, like, maybe in a future offering I would reorganize this course a little bit to include it more. And, like, a couple of the lectures I've pulled from the 1xC3 material as well. But like, towards the end of the course, I might, like, pop them in if we're doing well with respect to keeping ahead of the assignments. Like, I have to make sure that you guys know what to do for the assignments as the assignments are coming due. So, like, that puts some constraints on, what gets covered when. Like, I have to cover pointers before I expect you to do pointers. But other than that, like, I might be inclined to, like, move make files up, because that's, like, very, very useful material. Especially now that you know how to compile stuff. But, yeah. Yeah. So I wouldn't make it, like, for marks, because, you guys probably have enough already, but yeah, and it's also, like, it's kind of a weird course, because, like, it's got 4 hours per week of lab designated. But, oh, someone has said you can compile in GCC with GCC and VS Code though in the config file, can't you? Yeah, probably. It's you just gotta be careful. Like one of the reasons that right now there's a petition going around to try to get me to use VS Code during these lectures, and VS Code is not as bad as like some other things like Visual Studio, but you just get a lot of crap you don't need thrown in for no reason. And one of the things that I endeavor to produce with like examples I do in class is like specifically, let's get this as simple as humanly possible, And I know people are like, oh, tool support. And I'm like, okay, tool support. But, if it's a hello world or something at that level, you shouldn't need tool support, right? You should just be able to do it in a text editor. It's like I'm trying to teach the general thing that every system, like, no matter what your IDE is, or what its, like, extensions or autocomplete or whatever it's using, whatever it gives you, if you like remove, like I'm trying to teach the set of features that are common to all IDEs, right? The set of features that are common to all programming environments that you might be in, and particularly with C. I've said this a couple of times already. Unix is the IDE for C development, so yeah. Question about the assignment. For the assignment, since the autocomplete removes everything in the main function, how will your functions be called? Does it just make another main for grading? Yes, that's exactly what it does. So the other thing that you'll notice about the C files, the C code stubs that we've given you, is that they all import assert.h. There's a reason they all import assert.h. It's because we use assert.h to test your code. So please don't mess with the imports as well. So yeah, that's essentially it. We take your main function, delete it, substitute our own main function, and that main function, the new main function, performs the hidden test that we want to test your code with. But yeah. Yep, cool. Well, that's about I'm about out of time for today, so I'll be seeing you all tomorrow. Have fun. Try to enjoy the weather while it lasts, and yeah. Okay, so one more. Okay, so it doesn't really matter what we have in the main function when we submit it. That's correct. You don't have to delete it, or you don't have to have it in a particular format or anything. We are going to delete it and replace it. So you don't have to worry about that. Okay? Good. Take her easy, folks.